Okay, howdy. So this video, I want to talk about one of the applications of systems of equations. Sometimes you'll see books or videos or whatever split them up into different types of applications. But for the most part, the majority of them are going to be mixing type problems. So it might be actually mixing, so things like mixing antifreeze and water or alcohol and water. It's almost always something in water. But it could also be just mixing in other senses. So you might have, in the case we have for this problem, a mixture of nickels and quarters. It's still a mixture, just not in the sense of a solution like in chemistry, but it's a mixture nonetheless. There are other applications, ones that involve, say, distance as related to rate and time. And of course, there are also just number puzzle problems. You know, if you have two numbers and they add up to some value and one is some amount more than the other, those also work. But let's go ahead and look at this mixing problem. So the idea is you found a jar of coins, and all the coins in there are nickels and quarters. And so you put them in a coin counter, and the counter says that there were 154 coins, and the total value of those coins is $19.10. Now, we are going to have to assume that the coin counter is correct for this problem. If the coin counter is incorrect, then our solution isn't going to make sense. But so assuming that the coin counter is correct with this information, how many nickels and how many quarters were in that jar? So the first thing we need to do is give a name to our unknowns. So I'm going to use an N for the number of nickels in the jar, and I'm going to use Q to be the number of quarters in the jar. So there's a couple things we have in here. We have that there were 154 coins. So what that tells us is if you take the number of nickels and add that to the number of quarters, you should have 154. So in other words, N plus Q equals 154. We also have over here that there is a total value of $19.10. So that means we have to take the value of the nickels, add the value of the quarters, and that should equal $19.10. So first we need to note that the value of nickels is 5 cents per nickel times the number of nickels. In other words, $0.05 per nickel times the number of nickels. And so that would be 0.05 N as the value of the nickels. Similarly, if we take the value of quarters, which is 25 cents, in other words, 0.25 of a dollar, this is per quarter, and multiply it by the number of quarters, well, that's going to be 0.25 times Q, and that's the value of the quarters. So if we put that together, that means if we drop the units, since everything will have the same number of units, it'll be dollars, right? Dollars here, dollars here. That's why I used $0.05 instead of 5 cents, and $0.25 instead of 25 cents. Okay. So if I add those together, we get 0.05n plus 0.25q equals 19.1. I don't need to write the 1, 0, right? We tend to do that when we talk about money, but we really don't need to mathematically. So these are our two equations. And we can see that there's two equations, two unknowns, and these are both linear equations. So we can solve this system using any of the methods that are available to us. I'm going to go ahead and solve this one using substitution. So I'm going to take this first equation here and I'm going to solve for one of the variables. So I'm going to solve equation 1 for n. So if I simply subtract q from both sides, I'm going to get n equals 154 minus q. Okay, then I'm going to substitute that into the other equation, into equation 2. Okay. So we have 0.05n, but instead of n, I have substituted 154 minus q. And then I have the rest of the equation, which is unaffected by the substitution. So let's go ahead and distribute the 0.05. Let's do some scratch work over here. Okay, so we get 770 if it were 154 times 5, but this is 154 times 5 hundredths, so that means we're going to get 7.70, in other words, just 7.7, minus, when I distribute the 0.05 times q, we get 0.05q, negative 0.05q, and then I have the rest of the equation unaffected so far. Okay, so let's go ahead and combine these like terms here. So this is 0.20 or just 0.2 q. Now I'm going to subtract 17.7 from both sides. Let's again do a little bit of scratch work over here. Okay, so I get 11.4. So I have 0.2 q equals 11.4. So if I divide both sides by 0.2, in other words 2/10, 11 and 4/10 divided by 2/10, I can simply multiply by 10 over 10, since those are both tenths, which gives me 114 divided by 2, and therefore I get 57 for q. So what this means then is n, which was 154 minus q, will be 154 minus 57. So again, do some scratch work over here. And I get 97. So we've now solved our system of equations. We should go and check those values in here. So if we take 57 and 97 and add them, well, that would be 50 plus 90 and then 7 plus 7. So 50 plus 90 would be 140, and 140 plus 7 plus 7 would be 140 plus 14. And so sure enough, we do get 154. This one will take a little bit longer to check. If we take 5 times 97, okay, That's the same as 97 times 10 divided by 2. So in other words, half of 970. So let's see, that'll be the same as 450 plus 35. So I get 485. Okay, so that would be 4.85 here. And then we want to add that to what we get when we multiply 0.25 times Q. Well, Q was 57, and 0.25 times something is the same thing as a quarter of that. So I'm just going to take that 57, divide it by 4. Okay, so that gives me 14.25. In other words, $14.25. Okay, so I have $4.85 from the nickels, $14.25 for the quarters. Side note, because this is money, I could have also considered that when taking into account when finding the values of these. So 97 nickels, how much is that worth? Well, if it were 100 nickels, that would be $5. And so I'm 3 nickels short from $5, and 3 nickels is 15 cents. So I could subtract 15 cents from $5 and get $4.85, and so on. So you can do this in a lot of different ways, play around with the numbers and whatnot. But anyway, so we add these up, and sure enough, we get $19.10. So we can check that off. So we are happy with our solution. Now it just comes a time to answer the actual question in the problem. So the question was how many nickels and how many quarters were in the jar. So let's go ahead and write our final answer to that. So there were 97 nickels and 57 quarters in the jar. And that's it. I hope you found this helpful and have a lovely day.